Okay, all right. So, a very good evening to all. I welcome you all in this today live session, Big Five. So, in the last session, we have discussed the problems based on the voltage drop and power loss calculation in the power distribution networks. And in this session, that is session number 5, we are going to see problems based on the reliability for this power distribution networks. So, in the reliability model, there are two parts. One part is that in which we are going to see these various reliability indices, and the second part where we will see these mathematical models for reliability in power distribution network. So in today's session we are going to see the various types of reliability indices for the power distribution networks, so power distribution systems. So let us begin today's session. As usual, we will revise the theory and concepts that we are going to use for this for solving the assignment. So coming to this first slide, in which we are going to see the difference between outages and interruption. So these are most of the time conflicting terms that most of you may be confused with this what is outage and what is interruption, and what is the clear difference between this outage and interruption. So outage, if you see outage, then outage is the non-availability of operation of certain equipment, while this interruption is the loss of service to one or more consumers or one or more customers. So this outage is related to this equipment, while the interruption is related to the customer side. So this therefore you can say that outage may or may not cause interruptions. It is not necessary that if some equipment is not available, not providing operation, then that cause interruption. So this outage may or may not cause interruption, while an interruption may occur due to one or more component outage. So, and now if you see the various types of outage and interruption, then outage can be of three different types: host outage, scheduled outage, and partial outage. Host outage means this equipment taken out of service on emergency basis, while the scheduled outage means equipment taken out of service for preventive maintenance, while partial outage means this equipment operated at reduced capacity. So from the word itself defines what are the different type of outages. And similarly, the interruption can be categorized into these primarily four types. The schedule interruption means due to schedule outage, we have clearly defined when this interruption is going to happen, and then momentary interruption that occurs for a few seconds, temporary interruption that occurs for few minutes, and then sustained interruption that occurs for few hours. Now the major challenges for reliability assessment. So these are the one major challenges. First one is the efficient data on reliability performance, and most of the interruptions of distribution networks are caused by severe weather related interruption and for inadequate maintenance. And this distribution system reliability can be improved by timely identification and response to failures. So these three are major challenges for the assessment of reliability in power distribution networks. Now, in this uh, session, we are going to solve problems on the various reliability indices, and these can be categorized. If we see these reliability indices, these can be categorized in mainly three types: the reliability indices for sustained interruptions, and reliability indices for momentary interruptions, and load and energy based indices. So most of the problems being asked in this assignment are of based on the sustained interruptions and the load energy based indices. We have not considered here momentary interruptions because the questions are not based on this momentary interruptions. And the previous assignment also, the questions are based on these sustained interruptions and load energy based indices. For the reliability indices for this momentary interruption, you can refer the NPT lectures where sir has shown, Ganguly sir has shown many different reliability indices based on these momentary interruptions. So in today's session, we will focus on the sustained interruption based reliability indices and load and energy based indices. Mainly these SciFi, SciDi, CAFI, CAIDI, ASAI, ASIDI, CTAIDI, and this load energy based indices are ENS, ANS, AENS, energy not supplied, and then ACCI, and this load energy based indices, mainly this ENS, plays an important role for planning of power distribution networks. Now, what are the significance? What are the uses of these reliability indices? So this, uh, with the help of this reliability indices, most of the utilities just understand how this distribution system is performing, and they are using one or more of the reliability indices, because one reliability index is not enough to give the information about the reliability of a power supply. So, like for example, some of the reliability indices which are formulated for sustained interruption may not reveal momentary interruption. So they may use one or more of the reliability indices to understand how the distribution system is performing, how the distribution system is reliable. Now, what are the costs that are associated with system reliability? There are three important this cost that associated with system reliability. The first one is investment cost, that we that is referred to utility side cost, and then second, customer interruption cost, and then we have customer damage cost. So this customer interruption cost and customer damage cost are the costs that are related to customer side, while this investment cost is related to utility side cost. Investment cost that is used to achieve a desired level of reliability. So these are terms only, means what are the meaning that here sir in the NPT lectures that are given. And the customer interruption cost that include the cost of production loss for process industries, means some losses happen for industries in their production due to this power outage, power interruption. So this refers to the customer interruption cost. While this customer damage cost, if applicable, it is not in some places it may be applicable. So the meaning of this customer damage cost is that utility has to pay some penalty to customers for power interruption. So that are the meaning of this cost that associated with the system reliability. Now coming to this graph where it is shown about the reliability and cost. If you see this middle curve that denotes the cost of investment, and this lower one that shows the interruption cost. And in the x-axis, we have system reliability, and the y-axis cost. So if you add up this cost of investment and interruption cost, then this top one that denotes the total cost. So if you see here, this cost, if the cost of investment is high, the interruption cost is lower. Means whatever the losses happen due to interruption, that becomes lower because this reliability increases. So here you can write this. Here I am just providing the summary of all the NPTEL slides. For detailed things, you can refer to the NPTEL videos. So these two cost components conflict with each other. And one can easily understand why they are conflicting each other, because this, as the cost of investment increases, this interruption cost becomes lower. That's why this both curves are conflicting. Both cost components are conflicting with each other. On in the x-axis, if you see, then this is 0% reliable. Means system reliability is 0%, and that means our distribution network is totally unreliable. And while this 100% system reliability means it is fully reliable. And here this middle point denotes this optimal cost, that we generally pick up that cost while planning for power distribution network. Now these are the theories, and now we will see some of the expression or formulas that are very useful for solving the problems and that we need to remember. And whatever the reliability indices, like most of the indices here we have taken for these sustained interruptions and the load energy based indices, so that we need to memorize. And if you practice more problems based on this reliability indices, then you can easily it will automatically you can have the idea of the expression. And meanwhile, if you have any doubt or concern, you can ask. You can interrupt me and you can ask your doubts. So let us see the first reliability indices, that is SAFE, System Average Interruption Frequency Index. So it is the ratio of total number of customer interruptions upon total number of customers served. And in this so if you do know notation wise, if you remember this, SAFE is sigma ni upon nt. So we will see how you calculate sigma ni, that is total number of customer interruptions, and how you will calculate the total number of customers served. As of now, just see how these terms are defined, how these reliability indices are defined. Then SAIDI is defined as system average interruption duration index. So it is the ratio of customer interruption durations upon total number of customers served. So SAIDI is defined as sigma RINI upon NT. So sigma NI, you know that this total number of customer interruptions. Here RI is the restoration time for each interruption event. So RI is the RI the restoration time for each interruption event. So the first SIFI means it is frequency index, while this duration index is the uh, SIDI is the duration index. So this SIFI denotes this customer interruption per customer served. So just remember the full form of these indices so that you can don't apply the wrong expression. And duration index, this will give the answer in terms of hour per customer served, interruption hour per customer served. Now this third term CAIFI, that is customer average interruption frequency index. So whenever this frequency term comes, then numerator will be this customer interruption, not this interruption duration. And this CAIFI is defined as total number of customer interruptions upon total number of customers interrupted. So CAIFI is sigma Ni upon Cn. Now the next term is CAIDI. CAIDI is customer average interruption duration index. So again the duration, so numerator will be the interruption duration hour. With the summation, it is the ratio of summation for customer interruption duration upon total number of customer interruption. So CAIDI is sigma RINI upon sigma NI. So if you see CAIDI, then you can also CAIDI write in terms of SAIDI and SAIFI. So the numerator of CAIDI is same as the numerator of this SAIDI, because sigma RINI, the numerator in SAIDI, numerator in SAIDI is sigma RINI, customer interruption duration hour, and then sigma Ni, the numerator of SAIFI, that is sigma Ni, the number of customer interruptions. So CAIDI is also can be written in terms of SAIDI and SAIFI. CAIDI is the ratio of SAIDI up to the SAIFI. Now ENS, this is term related to the load and energy based reliability indices. So ENS is energy not supplied. So when the interruption happens, power interruption happens, then some time taken to restore for power supply. So whatever the interruption duration, for that time the energy is not supplied to the network. So we are calculating this energy not supplied during that interruption event, during interruption hour. So energy not supplied is L average I into Ri, sigma L average I Ri. L average I, the average load connected to load point I, while Ri is the restoration time for each interruption event. Now ENS is very simple. If you know the ENS, that energy not supplied, then ENS is the ratio of ENS upon NT. That is NT the total number of customers served. So ENS is sigma L average I Ri upon NT. Now if you calculate ACCI, then average customer curtailment index. So it is the ratio of total energy not supplied upon total number of customer interrupted. So ACCI is ENS upon CN. ANS is very simple. If you know the ANS, average energy not supplied, then you have to take the average with respect to total number of customers served. While ACCI, here you have to take this term energy not supplied with respect to number of customer interrupted. So ANS we are taking with respect to the system. That is, we are not considering whether the customer interrupted or not. We are taking with respect to customer served. While ACCI, we are taking the with respect to customer. So it is with respect to the customer interrupted. So here we are denoting the CN, that is the total number of customers interrupted, and this customer is counted only once, regardless of the number of times interrupted. So whether if a customer interrupted twice, then customer is counted only once because the customer is repeated in the next interruption. So uh, if you correlate the terms, like here this first term is SAIFI and second term is SAIDI. So it is with respect to the system that these interruption statics over the entire customer base or system. Means these are for entire customer base. That's why we have taken SAIFI and SAIDI with respect to the NT, that is total number of customers served. It does not refer that whether customer is interrupted or not. We are considering over the entire customer base or the system. While if the customer term comes, then either it is related with CN or sigma NI. So that I have denoted here. This sigma NI is the denominator in this KID, while in CAIFI, CTAIDI, ACCI, the denominator is CN. Means, means the total number of customer interrupted, while this sigma NI is the total number of customer interruptions. So in this reliability indices, if S denotes the system while C denotes the customer, then you have to take its denominator, whether I am writing the denominator correct or not. If system comes, then it is by default with respect to NT. It is not with respect to the customer interrupted or not. So it has to take the entire system over the entire customer base, that is total number of customers served. If in the reliability indices, if customer term comes, then you have to correlate with the customer interrupted. And in customer interruption, there are two things, like one is CN and one is sigma NI. In CN, we are counting the customer only once, regardless of the number of times interrupted. While in NI, the number of while the NI denotes the number of interrupted customer for each interruption event during reported period. So sigma NI will denote the customer summation of customer that interrupted for different interruption event. I hope it is clear. Means how you can correlate with the system and customer based reliability indices. Clear? Any doubt you can ask. Ramesh, if you have any concern, you can ask. Otherwise, we can go ahead. So now coming to the next reliability indices, ASAI, Average Service Availability Index. Average Service Availability Index. Ramesh, is everything okay? Are you able to understand?
Yes, sir. We are able to follow.
Okay, okay, good. So now we are this 8th number reliability indices, that is ASAI, Average Service Availability Index. So here it is defined as the customer hours service availability upon customer hours service demand. So how we will calculate the hours availability, the numbers of hours service is available. So the total number of customers served is NT, and you have to multiply with number of hours in a year, that is 8760, and then for each interruption the duration of hours the service is not available. So you have to subtract from this from the number of hours service is available. So it is sigma RINI. We know that RI is the restoration time for each interruption event, and NI is the number of customer interrupted during each event. So you have to subtract from this NT into 8760, and in the numerator it will be NT into 8760. So it is ideal one. Means if there is no interruption happen in a year, then service availability for the customer is NT into 8760, and the customer hours service is unavailable, then this is sigma RINI. So therefore, this customer hour service availability you can write in the terms of NT into 8760 minus sigma RINI. So ASAI is average service availability index. Now ninth term is ASIDI, average system interruption duration index. So it is with respect to total connected load. So we have seen this AENS also, average average system duration, average system interruption duration index. So ASIDI is the energy not supplied with respect to LT, total connected load. We have seen AENS also, average energy not supplied. So average energy not supplied ENS upon NT, that is total number of customers served. So ENS is ENS upon NT, and we have seen one more term ACCI. This is ENS upon CN. Average customer curtailment index. So these terms are related with ENS. So I have written all the terms together here. So you don't confuse with all these terms. ENS, you know, L average into RI, sigma L average into RI. Then ENS with respect to total number of customers served. Then ANS is ENS upon NT, while average customer curtailment index means it is respect to with CN. That is, we are counting the customer only once regardless of the number of times interrupted. So ACCI is ENS upon CN, and then ASIDI. So it is ENS upon LT. Now next term comes the CTAIDI, customer total average interruption duration index. So CTI is the ratio of customer interruption duration upon total number of customer interrupted. So CTAIDI is hybrid of CAIDI. Here we know that this CAIDI is with respect to total number of customer interruption, while CTAIDI is the with respect to customer that is counted only once, regardless of the number of times interrupted. Here I am writing both the terms. CA CAIDI is sigma RINI upon sigma NI. Therefore, the CTAID and CAIDI you can correlate and remember both the expression. CTI is hybrid of CAIDI and is calculated the same except that the customer with multiple interruption are counted only once. So in CTID, the customers having the multiple interruption are counted only once, while in CAIDI, for each interruption, we are counting the customers separately and we are doing the sum up. So these are all the reliability indices, and these are very simple. If you just give 15-minute time and just correlate all these terms, and I hope all these reliability indices will asked in the exam, because from the last 3 years I have seen the most of the problems are based on these 10 reliability indices. SAIFI, SAIDI, CAIFI, CAIDI. Important terms are, if you see the system, then you just go with this total number of customers served, either the customer affected by interruption or not. If system term comes, then it is telling about over the entire customer base, over the entire system. It is not referring the customer interrupted or customer interrupted only. While this C term comes like customer, so it is with respect to the customer interrupted. So if the customer interrupted means either it will be CN. Here we are counting the customer only once for any interruption, while sigma NI we are calculating the customer separately for each interruption in event, and we are doing the sum up of all the customer. And this frequency means it will give the unit in customer per interruption per customer served or customer interrupted, while this duration terms comes, then it will give the answer in number of hour interrupted per customer served or per customer interrupted. Then ENS, with ENS there are four terms related. First one is ENS, then AENS, average energy not supplied, then ACCI, average customer curtailment index, and then ASIDI. So these four terms are related with ENS. Energy not supplied is sigma leverage I. ENS is ENS upon NT, and ACCI is ENS upon CN, and ASIDI is ENS upon LT. And this average service availability index, it will give the number of customer hour service is available. So you can easily find this expression while deriving these terms, like for what number of customer hours service is available. So this NT denotes total number of customer served from the power distribution network. So NT into 8016 hours is customer hours, while this customer hours for the service is not available. So sigma RI is the duration for which the service is not available, and NI is the customers for this power is interrupted. So sigma it will be subtracted from NT into 8060. So you will get ASI, average service availability index. And then last term CTAIDI. If you know this Kaidi is referred with the sigma NI. This customer is counted multiple times in Kaidi, while CTAIDI, the customer is counted only once, that is having multiple interruption. So I hope you can easily correlate all these terms and remember all these expression. If you don't remember this expression, you cannot solve the problem in exam. And to remember this expression, first advice I will give that you just first remember the full form of all the reliability indices. If you know the full form, then you can derive the expression also, because from the full form only you can correlate the terms. What should be the numerator and what should be the denominator. So I have noted down all the important reliability notations. First one is the total number of customers served. So that we denote by NT. Then we denote total number of customer interruptions. That is sigma NI. And third term is denote total number of customers interrupted. That is CN. In CN, the customer is counted only once, regardless of the number of times interrupted. Then we have customer interruption duration, that is denoted by sigma RI, where Ri is the restoration time for each interruption event. You can also tell that this Ri is the time during which the power is not being supplied to the customers, and LT the total connected load. So these are all important reliability notations and terms that we need to know. And here obvious is that sigma Ni is greater than Cn, because here the customer is counted separately for each interruption event, and we are doing sum up of the customer interrupted for the for the interruption. While in Cn, this many customers are interrupted in various interruptions. We will count that type of customer only once. So till this point, we are finishing all this expression related to current assignment, and this assignment is so easy. If you know the expression, then you will easily get 100% marks. Till here, any doubt? Otherwise, we will move to the problem solving part. Is everything clear?
Yes, sir.
Okay. Okay. So let us come to the first problem. So I have noted all these notations. So first we will find the notation, and then we will find all the reliability indices. Here in this problem. They are asking that a distribution feeder is connected to 6,000 customers. The record shows that there are 5 fault events in a single year. Total connected load is 20,000 kilowatt. Total number of customers who experience at least one interruption is 1500. Now just tell me, I will ask 3 point here from this data, like NT is how much from these lines? Can anyone tell? NT is what? So I will write here also. Yes, I think I got one. Yes, Ramesh, 6,000. So the first line is saying that distribution feature is connected to 6,000 customer. So total number of connected is the number of customers served is NT. So NT is 6,000. So the first notation is the total number of customers served. Total number of customers served is NT and it is given in the first line, that is 6,000. Now now total connected load is how much? Total connected load, total connected load is, we denote total connected load by LT. So tell me what is the total connected load? So what is the total connected load? Yes, yes, the total connected load is 20 kilowatt. And it is given as in the second line. So LT is 20 kilowatt, sorry, 20,000 kilowatt, and NT is 6,000. Now, and third question I am asking is total number of customers interrupted. And that we denote as CN. Total number of customer that we denote as CN. Tell me CN is how much? CN is 2400. No, it is not correct. CN is 1500, correct. That is the most confusing part. If I am asking CN or either am I asking as sigma NI. CN is 1500, where it is given this one. Total number of customers who experience at least one interruption is 1500. So at least one interruption, this denotes Cn. So it is 1500. Now I am asking the total number of customer interruptions. So that is different. Total number of customer interruptions. So it is sigma Ni. Sigma Ni is how much? Yes, Ramesh. Now it is correct. Sigma Ni is 2400. How will you calculate sigma Ni? So for each fault, the number of customer interruption is given. The number of customer interrupted in first fault, it is given as 500. So 500 in first event, in first fault event, 750 in second fault event, and then 1000 in third fault event, and then 50 in fourth fault event, and 100 in fifth fault event. So if you do sum up, then it will come as 2400. So sigma Ni, the total number of customer interruption, that is coming as 2400. Now I'm asking about last term, that is customer interruption duration. Customer interruption durations. It is denoted as sigma Ri Ni. You find sigma Ri Ni. So Ri is the registration time for each fault. So this one is Ri, duration of interruption given in hour. So it is Ri. So now we will just take multiplication of 1.5 into 500 for the first fault, and then 2 into 750 for second event, and then 2 into 1000 for third event, for fourth event 1 into 50, for fifth event 2 into 100. So it will come 750 plus 1500 plus 2000 plus 50 plus 200. So it will come as 4500. So these five terms you should know before all the reliability indices. So let us solve. Just write down all these terms in your notebook. Then we will just put this expression, and we will easily find the reliability indices. I hope you all have written down all these terms: NT, LT, CN. NT is 6000, LT is 20,000 kilowatt, CN is 1500, sigma NI is 2400, sigma RI is 4500. So let us come to the first problem. So in this problem, they are asking SAIFI. SAIFI. So SAIFI. What is the full form of SAIFI? Full form of SAIFI is System Average Interruption Frequency Index. And it is the ratio of, if you know the answer, you can type it on the chat box. Total number of customer interruptions on total number of customers. Sir, yes, correct. Ramesh, you're correct. D, the correct answer. Now what happened? I don't know what happened. It is not saved. So Sci-Fi, we know that it is ratio of sigma Ni upon Nt. We have calculated sigma Ni as 2400 and Nt as 6000. So it will give us 0.40. So D is the current answer. If you write the unit, then sigma ni is denoting the interruptions. Interruptions per customer served. So let us come to the next one. Next one is you have to find the SID. So you have to find the SID. You write your answer chat box if you have already found it. So SID is some average interruption system average interruption duration index. So SID is the ratio of customer interruption durations on customer served. Since it is related to system, so it is related with the total number of customers served. System average interruption duration index. So SID is sigma Ri Ni upon Nt. So we have found SIFI. SIFI is sigma Ni upon Nt, while SID is sigma Ri Ni upon Nt. Anyone got the answer? So I got some response. DB is saying C. Yes, C is correct. Very good. So we have already found sigma RINI customer interruption durations. So sigma RINI we have found as 4500 upon total number of customers served is 6000. So it is 0.75. If you write its unit, then it is 0.75 hour per customer served. So it is the denoting the interruption hour per customer served. And now if you write in the minutes, then you have to multiply with 60, then it will coming as 45 minutes, 75% of 60 minutes. So 45 minutes of interruptions per customer served. So this is SID. First we have found the SIFI, that is frequency indexed. In the second problem, we have found the SID, that is duration index. So here we have taken sigma Ri Ni, but in the first problem, we have taken sigma Ni upon Nt. Now come to the next problem. In this problem, we have to find the Cauchy. So for all reliability indices, first write the expression. So it is related with customer. So now the system is term is not coming. So we have to denominator either will be sigma ni or cn. So chi phi is the customer average interruption frequency index. So it is the ratio of total number of customer interruptions upon total number of customer interrupted. So this is the expression chi phi is sigma ni upon cn. Ramesh is saying B. Yes, Ramesh, you are correct. B is the correct answer. 1.6 is the correct answer. So B is the correct answer. And the last problem, 0.75 is the correct answer. So you have to just substitute the value sigma ni is 2400 upon cn is 1500. So it will come as 1.60. If you write its unit, then 1.60 interruptions per customer interrupted. So this is chi. Now in the fourth problem, we have to find the chi. So all of you find this chi and let me know the answer. You type it on your chat box. I'm just coming in 1 minute. Anyone got the answer? Oh, I got one response. Devi saying C. Yes, correct. 1.875 is the correct answer. Just 2% are responding, Ramesh and Dev. Other one also you try. It will, if you practice more, then it will be good for you. Kaidi is customer average. If you have any doubt also you can ask. Otherwise, just request you to try all the problems. Customer average interruption duration index. So it is the ratio of customer interruption durations upon total number of customer interruption. So is sigma Ri Ni upon sigma sigma Ri Ni we have calculated it is 4500. Sigma Ni is 2400. So it will give you 1.875 as the answer. So if you write its unit, then it will be number of hours customer served, customer interrupted. In the minute, it will be 112.5 minute per customer interrupted. So now in the fifth problem, you have to find the energy not supplied. So all of you try this problem, then I will solve this problem. You have to find the energy not supplied. I'm just writing the question first, then you have already calculated, you can type from chat box. ENS is energy not supplied. And it is the summation of L average, L average I into Ri. So here a leverage I is what? Average load connected to load point I, and Ri is the restoration time for each interruption event. So Ri is the restoration time for each interruption event. So this is Ri and this is a leverage I. So you have to just do the multiplication and you will get the answer. Anyone got the answer? Yes, I got one response from Dev. He's saying D. Another one? Any other one? Yes, D the correct answer. 33,600 is the correct answer. So you have to just sum up by multiplying with load interruption for the fault event with the number of interruption hour. So ENS is 1000 into 1.5 plus 6000 into 2 plus 9000 into 2 plus 500 into 1 plus 800 into 2. So ENS is, it is 1500, then 12,000, and then 8,000. 18,000, then 500 plus 1600. So if you sum up these both, then it will be 30,000, and last terms is 2100. All will come as 6,600 kilowatt hour. Therefore, D is the correct answer. Now let us come to the next problem. They have asked this AENS, average energy not supplied. So it is simple. If you know the energy not supplied, then you have to find the average of it with the customer served. Total number of customers that is being served by this distribution feeder. Only two person are responding. Divi and Ramesh. Other one you also try and give the answer. Average energy not supplied. So ENS is 33,600. Now you find AENS. I got one response. Yes, Ajmer is saying B. Yeah, very good. B the correct answer. 5.60. B is the correct answer. AENS. 5.60. AENS is average energy not supplied. So it is the ratio of total energy not supplied upon total number of customers served. Total number of customers served. So ENS upon NT is the average energy not supplied. ENS is sigma L average I into Ri upon NT. So it is 33,600 kilowatt hour upon NT is 6,000. So it will give you 5.6. 5.60. If you write its unit, then it is 5.60 kilowatt hour per customer served. Now let us come to seventh problem. So in the seventh problem, they are asking about ACCI. So ACCI is average customer curtailment index. I am just providing the expression. You will find the answer of it. ACCI, average customer curtailment index. So it is the ratio of total energy not supplied upon total number of customers interrupted. So ACCI is ENS upon CN. Total number of customer interrupted is CN. So ENS is 33,600 and CN is 1500. Now you will find the ACCI. So anyone got the answer? Ajmer, Dev, Salini, Dev and Ramesh. 5 attendees are there. Dev is saying A. Yes, correct. You are correct. Very good. She is saying A. Yes, A is correct. ENS we have found that is sigma L average I into Ri upon Cn. So it is 33,600 upon Cn is 1500. It is 22.40 kilowatt hour per customer interrupted. So AENS is with respect to the system based. That's why we have denominator, we have total number of customers served. While ACCI, we have calculated with respect to customer base. So that is with respect to total number of customer interrupted. That means CN. Now let us come to the next problem. Here we have to find ASAI, average service availability index. So a little bit calculative, but you can easily find it. So ASAI. Yes, Ajmer, correct. A is the correct answer for the seventh number problem. So I am just providing you the expression. ASAI, average service availability index. So it is customer hours service availability upon customers hours service demand. So you have to find the customer hour service demand. So how you will find the customer hour service demand? It is very simple. So in the denominator first we will add the customer hour service demand. So it is number of customers served into the number of hours in a year. So 18 to 8760. So this is the customer hour service demand. So in the numerator we have to find the service availability. So first we write NT into 8760 minus the service is not available. So service is not available for the customers that is interrupted. So it will be sigma into RINI. So this is the final expression. Average service availability index. It is little bit calculative, but its expression is very easy to remember because it is telling about the average service availability index. So the denominator will be customers hour service demand. So the how will calculate customer hours? So customer hours is number of customers served into the number of hours in a year in 2007 8760, and in the numerator you have to subtract from the customer hours for interruption. So customer hours interrupted is sigma Ri into Ni. Now you just give the answer. I got one response. DV saying B. Yes, correct. Very good. B is the correct answer. So just let me calculate this one. So NT the number of customers served. So NT is given in the problem. So it is given as 6,000 customers. 6,000 into 8,760, and we have found sigma RINI. We have found sigma RINI is 4,500. So we have to subtract 4,500 from this value upon 6,000 into 8,760. So in numerator it will come as 524500, and denominator will be 525640 into 100. So it will be 99.9% of service available. 99.99% of service availability. And if you write in the per unit, if you not multiply with in the 100, then it will come as 0.999 unit hour availability. So for this problem, B is the correct answer, 99.99%. That is average service availability index. So now come to the next problem. Here we have to find the ASIDI. ASIDI. So let me provide you the expression. ASIDI. If you got the answer, you can type it in the chat box. ASIDI. Average system interruption duration index. And it is the ratio of total energy not supplied to the total connected load. I think I got one response. Who responded? Ajmer. Ajmer is saying B. 1.68. Yes, correct, Ajmer. You are correct. 1.68 is the correct answer. So ENS we have found that is 33,600 kilowatt hour on LT. That is total connected load. So it is 20,000 kilowatt. So it is coming as 1.68 hour. B is the correct answer. Now let us come to the last problem of today's session, that is CTAIDI. CTAIDI. You try yourself and let me know the answer. CTAIDI. Its full form is customer total average interruption duration index. And it is defined as the ratio of customer interruption durations upon total number of customers interrupted. So CTAI TI is sigma RINI on CN. CTI is sigma RINI upon CN. So it is similar to Kaidi. In Kaidi, we take to total number of customer interruption, but here we are taking with respect to total number of customers interrupted. So CTI business. Yeah. So Ajmer is saying D is the correct answer. Yes, very good, Ajmer. D is the correct answer. 3 is the correct answer. So sigma RINI is 4500 and CN is 1500. So we will get 3 hour per customer interrupted. And we have also found the Kaidi. So Kaidi expression with respect to the total number of customer interruptions. So it is Kaidi is sigma RI Ni upon sigma Ni. Sigma RI Ni is 4500 upon sigma Ni is 2400. So it was coming as 1.875 hour per customer interrupted. So it is obvious that CTAID will be CTAID will be always greater than KID. CTAID will be greater than KID. Why it is so? Because in denominator we have in KID sigma Ni. So since denominator we know that Cn is less than sigma Ni may be equal. So if it is equal, then this equal sign will come here also. Cn is less than sigma Ni. So that's why CTI will always coming greater than KID. So this is all for this current assignment. If you have any doubt, anything you want to ask, you can ask. So what are the conclusion? So I just want to again revise. So in this current assignment, all the problems based on this reliability indices. And for finding the reliability indices, you need to know the expression. You need to know the formula. And how you will know the expression? You will know the expression by understanding each terminology. If you know each term, like whatever the reliability indices, first you know its full form. What is this correct full form? If you know the correct full form and you know each terminology, like let me just briefly give you, like first thing is like here, if any terms comes like Saifi and like this Kaifi terms. So these terms, if you see F term, then these terms measures only frequency. And like if term come like Saidi or like term just we have seen CTAIDI, Kaidi, and CTIDI, so it is the terms come. So it will measure measures duration. Sorry, right, not only measures frequency. So frequency means interruption per customer interrupted or per customer served, and duration means hour. So it measure durations means it will give you in terms of hour, and frequency means like we have Taiphi and Kaifi means interruptions. Interruptions, interruption per customer served or per customer interrupted. So these things are important. If frequency terms, then it measures frequency, while if D term comes in the reliability indices, then it measures duration, that is number of hours customer interrupted. Now, one more important thing, like what is the difference between Cn and sigma Ni? So for this, I will write one line and you will just understand what it does mean. if the same customer is interrupted, the same customer is interrupted 3 times, 3 times in a year, then that constitute constitutes that constitute 3 customer interruptions. So that is the difference Cn and sigma ni. Here the same customer is interrupted 3 times. So that will constitute ni as 3. Sigma ni will be 3. While Cn is only 1 because here this customer is repeated again and again. And and let us know this S term and kaphi term, Saidi term, like we have seen Saidi and we have seen Saifi. So here S, what it denote S? You know A means average, I means interruption. We have seen D means duration, F means frequency. So you can write one line for this. The S the S term it means that means that these indices, these reliability indices average their interruption, average their interruption statics, average their interruption statics over the entire customer base or the system. Over the entire customer base or system. So over the entire customer base or system is it is referring with NT. And now suppose if we are having this CAFE or like CTAIDI. So here we have C term CAFE. Then what it did denote? Then you can write C means that these indices refer to only customers who experience who experience interruptions. So here I just want to ask that refer to only customers who experienced interruption. So here Cn or sigma Ni will come. What it will come? Anyone can tell? Here means like S term I told you that denotes the over the entire customer base or system, that is NT. Now this C term refers to only customer who experience interruption. So can you tell the notation like sigma Ni NT Cn? Yes, Cn is correct, but both can come. Like some may be sigma Ni, some may be Cn. So you have to see the based on the interruption. Like in CTID, we know that this Cn we use, and in KID we use sigma Ni. So either it will be sigma Ni or Cn, because in both this we count the customer interruption. In Cn we count only once, while in sigma Ni we count separately for each interruption and we just add together. So this is for uh, this is the last summary that I want to provide, and from uh, from this slide onwards, you will have the questions based on this. So let me copy this. It's better to put here. So from this slide, it is 2023 problems, NOC 20. All right. So from these slides, this NOC 2023 problem. Let me tell this as just delete this. So this slide just I want to have a revision what we have understood. So in 2023, if you see all the problems are similar that we have solved. So all this even the reliability indices are similar, no change. Means all are based on this uh, sustained interruptions and load and energy based indices. And now if you come to 2022, then again all the problems are based on a similar reliability indices. The indices they have asked are all similar. So you just you can revise, but if you know the expression, there is very little chance you will have any problem. You will have any doubt. Yeah. Means you will have wrong answer. So Ramesh is asking reliability function and unreliability function. So you can go through the search slide. You can go through the search slide. In the next class, we will see the mathematical model of it. But for how you can say, but for have a basic idea, because one question they have asked on this reliability, right? So if you go to the search slides, I will suggest you where you can find. So these are all reliability indices. So in module 3 part 1, then if it comes After covering all these reliability indices, see there are some momentary indices also given. MAFE and load energy based reliability indices. These are examples. Now this mathematical model of this reliability comes. So this we'll see in the next session, because most of the problems in the next assignment will you find out this mathematical concept of reliability. But for one question that you are asking, Ramesh, you can refer to these slides number 33 and 1 minute. You can refer this slide number 33 where they have find the general relativity function, and then this is the function like they have shown here. RT the relativity function and then FT the unreliability function. So it is just like probability. If it is reliable, it is 100% reliable, then FT will be 0. And if it is not reliable, 0% reliable, then FT will be 100%. So RT plus FT equal to 1. So FT the failure function, which can be called as unreliability function. Therefore, the probability of the component will not fail at a given time, which define the reliability of the component. Thus, the reliability function can be expressed as RT equal to 1 minus FT, where RT the reliability function and FT the unreliability function. Any other thing, Ramesh? Okay, Dev and Ramesh, if you know the concern, then we can stop today's session and we will meet on the next Sunday, where we will study the mathematical models of reliability. Okay, good night.
Night, sir.